Let's take a look at applying equivalence, partitioning, and boundary value analysis together at the same time using the same requirement. So let's take a look at the requirement, and let's try to do what is stated here below, is to apply equivalence, partitioning, and boundary value analysis to identify valid partitions and valid boundaries. Okay? So we have users input price and order quantity to the system, which calculates total cost including any discount. Items can be ordered for any number up to 999, but the minimum order is for 5 items. Orders for quantities of 100 and above will receive a 20% discount. So we have already seen and spotted a couple of numbers present here in the text. We have also understood that the system is expecting 2 inputs. One of them is the item price and the other is the quantity that we want to order. Regarding the price, nothing is set. So let's focus only on the quantity of the order being conducted. This seems to be the major requirement that needs to be addressed as partition right now. Okay? And what happens when we are considering the order quantity? We have enough information here to see that we can choose any number up to 999. So the system will accept and will consider valid any input from 0 up to 999, because at least you should have an order of 5 items before actually producing and expecting an order to be conducted. So from 0 to 5, you have a valid partition, but the system will let you know that you need at least 5 items before conducting an order. From 5 to 100, we are expecting the system to place the order, okay, and provide you with the multiplication of the item price per the number that you have chosen for the quantity. All items or all quantities introduced from 100 and above will be applied, the order will be made, and it will receive a 20% discount. So the expected output will present to the user, your order has been made and you have to pay 100 or the quantity that you have chosen, the price that you have chosen, minus the 20% discount. Okay? So putting this as a table, you can actually see that from 0 to 4 you have a valid partition, from 5 to 99 you have a valid partition, and from 100 to 999 you have a valid partition. All the invalid partitions are concerned when solving this example. Okay? From the equivalence partitioning, you can look and you can write and design 3 test cases, 1 per each valid partition. So for each test case, you have an ID, an identification number that is unique. You put the item quantity that is the representative of each partition. So we have chosen here, for instance, 3, that is the representative of the partition 0 to 4, this one. We have chosen 50 as the representative to partition 5 to 99. And we have chosen 150 as being a representative of this last partition from 100 to 999. The item price should be something that could be the same for every test case or not. This is quite irrelevant here because we are not focused on that variable, okay? But you should enter what will be used to be compared with the expected result. So yes, you should have to provide the value here. Then we have only testing. We are only considering here the valid partitions. Then we have the actions, the steps that should be something that describes the interaction of the user with the system. You should enter the order for 3 and items should cost 5 euros. You should enter orders for 50 and items are at 10 euros. And at last, enter order for 150 and items at 2 euros. This implies that the total cost for the first case, since the sale is rejected, is the expected outcome. Okay, the sale is rejected, the cost and discount are not computed. For the test case number 2, the total cost will be 500 euros and no discount should be applied, so the sale occurs and the total cost is presented. In the last partition, we have the total cost, so 100 per 2 euros provides a total amount of 300, and then the 20% discount is 60 euros, and we have a total for the sale of 240. Okay? If we look at the BVA example, we will be looking at the valued boundaries. So we have a valued boundary as 0, 4, 5, 99, 100, and 99. This implies an additional set of 6 test cases that should also be described. So for each boundary, we have a specific test case. And for each test case, we have an expected outcome. So if we input 0, the sale will be rejected. If we input 4, the sale will be rejected. If we input 5 and 20 euros for each item, we will have a total amount of 100 euros and 0 discount. 99, where each item costs 10 euros, will imply 999 euros with a 0 discount, and the sale will be done with a 990 euros amount. And finally, we will have the discounts applied for the introduced quantity order and for the specific discount applied to the total amount that is being requested for the user. So we have 2 outcomes where you apply a discount and you have the sale with the corresponding total amount that is applied. And this wraps up for the BVA and EP example joined together.